Now that we've been introduced to the mole and we know how to do conversions using molar mass and Avogadro's number, we're going to add another step to it now. So now we're going to be able to convert not only between those things, but we can also include the idea of molarity. So let's talk about what is molarity. Molarity is a measurement of the concentration of a solution. So if something is highly concentrated, that means there's a whole bunch of molecules in that solution. If something has low concentration, then there's not as many molecules in it. So for example, you can go to the grocery store and in the frozen section you can buy these cans of fruit juice, such as orange juice, and it says highly concentrated on it. And you're supposed to mix it with water to make like a pitcher of orange juice, okay? So you're taking a highly concentrated can of orange juice, mixing it with water to decrease the concentration so that it tastes good. Okay, so our equation that you can add to your equation sheet is molarity equal moles over liters. Okay, so moles of the solute, that is the substance being dissolved within the solution, over the liters of solution. That's your total combined volume, your final volume. Okay, molarity is represented by a capital M, capital M. Okay, so molarity is moles per liter. That's your unit for molarity. So what does that mean? So for example, if you're buying acid, so if you're a chemistry teacher or you're a chemist working in a lab and you need acids to work with, you buy it by concentration. Do you need a 2 molar hydrochloric acid or do you need a 0.5 molar hydrochloric acid? Because what experiment you're doing will depend on what concentration you need. So what does it mean if you order 2 molar hydrochloric acid? Okay, well remember molarity is moles per liter. So if something is 2 moles, has a 2 molarity, then that means that there's 2 moles of hydrochloric acid per 1 liter. Okay, so there's 2 moles of the hydrochloric acid molecules in 1 liter. Okay, so that's how we are looking at molarity. So part of this should look really familiar. Okay, this top part, this is the same graphic that we saw the other day, where we knew that we could convert between grams and moles by using, by using the molar mass, grams per mole. Okay, that comes from your periodic table. We can convert from moles to number using Avogadro's number. Okay, so we can convert back and forth there. Now we're going to add this to it. We can convert between moles and liters using molarity, moles over liters. Okay, so make sure you wrote this in your notebook. That way you can use this graphic to help you as we move forward into some practice problems. Okay, so for example, how many grams of sodium chloride are required to make a 0.5 liter of 0.25 molar NaCl? Okay, so just like before, I have my baseline set up for me the same way as we did in yesterday's activity that you guys did, so that we can fill it in and make sure that we are able to cross off and cancel off those units that we don't need. Okay, now today, this question, my final answer is in grams, so I want to be able to cancel everything off and end with grams. Okay, so the first thing we're going to put in is our 0.500 liter, because that is not a derived unit, it's a full unit all on its own. There's not a top and a bottom. Okay, 0.500 liters. Now I know since I have liters here, then the next thing I need here would be what? What should go down here so that we can cancel? Hopefully you said liters, so we need liters down here as well. That way these 2 liters will cancel off. So what do I have where I'm going to find liter information? I have my molarity, because remember this means moles per liter. So this is the same thing as 0.25 moles per liter, okay? And just like we did yesterday, if we need to flip this, so if we needed moles on the bottom, we could flip it, but we need it just like this. We need moles per liter because we need liters on the bottom. Okay, so we can pop that right on in there. So 0.25 moles per 1 liter. That's going to cancel off my liters for me. Okay? All right, so now I am at moles. So in my graphic that I told you to write in your notebook, I'm in the center. I'm at moles. Now I need to go to grams. So how do I get from moles to grams? I use my molar mass. So this is where I need to use my periodic table to find that molar mass of sodium chloride. So I'll need to do some addition again. So sodium on the periodic table is 22.99. Chlorine is 35.45. Add those together to put into my chart, and we get 58.44 grams per 1 mole, because that's our molar mass. Mark off those moles. I'm left with grams, which is awesome because that's what I want. And then I just pop this into the calculator. So I do 0.5 times 0.25 times 58.44, and I will get 7.3 grams. Why 7.3? If I go back to my problem, this number has 3 sig figs, this number has 2 sig figs, and we always stay with the lowest sig figs. So since this one only has 2, then my final answer needs to have 2. So 7.35 grams. Okay, let's look at another practice problem. This one makes you set it up a little bit differently. So let's take a look. So we want to find the molarity of a 250 milliliter solution containing 10 grams of sodium fluoride. Okay? All right, so we want to find the molarity. That's our final. That's where we're going. Okay, so remember molarity equals moles over liter. Okay, looking at my problem, I don't have any moles and I don't have any liters. So, but I do know how to go from grams to moles using my molar mass. So I'm going to put my grams into my problem. And then I'm going to use my molar mass, so time to use my periodic table again. Sodium is 22.99. Fluorine is 19.00. Add those two together. So I can add those to my problem. 41.99 per 1 mole. This way, putting it in this way, my grams will cancel off. I'm left with mole. Okay, so I get 0.238 moles. Now I can put this right into my molarity equation, moles over liters. Okay, so my moles go right there, but now I need liters and I don't have any liters in my problem. I have to convert. So that's why we did conversion practice in the beginning of the semester. So we need to convert milliliters to liters. Remember, to do that, we need to move the decimal 3 places to the left. So this will become 0.25 liters. And then I just pop this into my calculator, 0.238 divided by 0.25, and I will get 0.95 molar, capital M, because I calculated molarity. Okay. Looking up at my problem, this one has 3 sig figs, but this one only has 2 sig figs. So my final answer should have 2 sig figs. If you need help with this, if you need some one-on-one tutoring, please get into contact with me so I can help get you where you need to be able to do these on your own, because independent practice is up next.